Now we're going to learn how to do addition and multiplication in the vector world. And again, this looks like a bunch of stuff, but when we get to the examples, it'll be pretty simple. It may actually be one of your favorite things that you do in pre-calc. So if we have two vectors, u and v, and k is a scalar, that just means it's a real number. It's not an imaginary number. It's just a number like 3 or 5 or negative 7, something like that. Then the sum of u and v is the vector, u plus v, and all we're doing is adding the horizontal components together from the two vectors and add the vertical components together from the two vectors. So that's addition. Scalar multiple, k times. Basically think of it like distributing. You're going to take this multiple, the scalar multiple k, and you multiply it in, so to speak, to both components so that you have k times u1 and k times u2. The opposite of a vector v is just like taking -1 times that. So it's exactly like what we had been doing up here in the scalar multiplication. You're just kind of distributing that -1 to both of the components. It just makes everything opposite. The difference, exactly the same as adding, only, surprise, surprise, you're subtracting them. Okay. Again, it's the horizontal components together and the vertical components together. So let's practice. All right, so we're starting out with u being 5,3 and v being -4, 0, and we're finding these. Now, if you want to take a shot at this and try it yourself and then check your answers as you go, that'll be great. Or if you start doing it and you want to stop and finish it yourself and then come back and check, that would be fine too. I'm completely sure that you're capable of that. So if I'm doing u plus v, I'm going to be taking 5 and -4. So 5 plus -4, which ends up being 5 minus 4. And then I will also be, for the other components, for the vertical, I've got 3 and 0. So I'm going to take 3 plus 0. And remember, the only reason that this one was a minus over here is because it was negative. So when I put these guys together, I have the vector 1, 3. That's addition. Subtraction, very similar. This time we're going to have 5 minus -4 and 3 minus 0. Same components, just subtracting them. So then we're going to get 9, 3 for the subtraction. Now the next one has the scalar multiples, and just like we have order of operations with real numbers, we have order of operations with vectors. You need to perform the multiplication first, then do the subtraction. So I'm going to lay this out here. I'm going to take 2 times the vector u, which is 5, 3, and then I'm going to add to it. Now I'm going to write this as an addition so I don't goof up here. I'm going to write it as plus a scalar multiple of -3, okay, from right there, times the vector v. So this is -4, 0. So then I'm going to kind of distribute those guys in, which means I will have 10, 6, and I will have 12, 0. And then I just need to add those two guys together. So I'm going to take 10 plus 12, which is 22. And I take 6 plus 0, which is 6. So there's that combination. Now v plus 4u, very similar. Extend that page a little bit so it's easier to see. So v plus u, I'm going to have -4, 0. Plus 4 times the vector u, which is 5, 3. Okay, so that means that I'm going to have, I think I will go underneath so I have more room. I have -4, 0, plus 20, 12. And then when I add those together, I get negative 4 plus 20, that's 16. And 0 plus 12 is 12. So 16, 12. So that's scalar addition, multiplication, scalar multiplication in a nutshell. So let's go on to the next section. Pause if you need to and look back over that, but I'm going on. Here are some properties that you might recognize. Now, these aren't many of these in your book, but they are true, and you may recognize them from real numbers, and these are properties that also work for vectors. You might recognize this as the commutative property. It doesn't matter what order you add vectors in, as long as you're doing all addition, you can move them around. This one we just have different groups or different associations, so this is the associative property of equality. And these two, generally speaking, and the second one probably looks a little bit more familiar to you, but they are both distributive property of equality. They just look a little bit different. Okay, so the rules that we had for real numbers also apply to these vectors. And I think that's where we're going to stop this one, and the next one will be unit vectors.